My name's John Lawson. I'm the City of Edinburgh Council's Archaeological Officer. I have a wide-ranging role in terms of protecting our heritage, largely through development control work, but also look after the Council's archaeological collections. In 1980, the cathedral decided to put some steps down to link the cathedral here, the main floor, to an undercroft. And as part of that, obviously it was within a nationally important archaeological site. The archaeologists were called in to excavate the site. I'm standing here in the Lady Aisle of St Giles Cathedral, and on the edge of the excavations we undertook in 1981. We're in the southeast corner of the church. And what we found during those excavations is approximately just under 120 in situ burials. That means in situ intact largely, along with the remains of quite a lot of other individuals which are mixed up remains. Dating from the foundation of the church in the roughly about 1124, right the way through to the mid-16th century. So the idea was to go back, look at information we found back in 1980, but we didn't do a lot of science at the time. And this is a real opportunity to bring new science into the project and work with fantastic partners.
Well, St Giles as a church was placed here at the same time as the borough was created. When the city was given its royal charter by King David I, the King also saw fit to put a church in its place and dedicate it to St Giles. So we've been here from the beginning, an integral part of what was the creation of Edinburgh, and we're very pleased to still be part of that today.
With 1124, that's kind of the date that everyone's working from. We know that was the first year of David I's reign, and he started to set out these new burghs, these new towns. And so when he set up a new town, the two kind of came together because a new town needs a church at the heart of it. But when exactly they started work is still a little bit unknown.
Well, St Giles is actually one of the most important archaeological sites in the city. It's the core of the city. It was the parish church from its inception in 1124. Although it's a grand cathedral, it started off as a smaller Norman church.
The original church we know would have been a lot smaller, probably at least about half the size of the one that we're standing in today. Romanesque, this is Gothic now, so much smaller congregation, several hundred people rather than several thousand that they had to fit in at any one time.
When we did the excavations in the early 1980s, what we found was 5 burial phases. And what we mean by a phase is a layer of time. Each one was roughly about 100 years, coincidentally, and it tied in with different phases of construction of the church.
The cemetery was here from the get-go. They needed somewhere to bury people, and you had to bury on consecrated ground. So in what is now part of the church, a bit further outside where I'm sitting right now, was the burial ground. So when excavations went on, they found some of the earliest burials inside the current church, but outside the original church, and that was for everybody in the burgh. So peasants all the way up to the elites.
Well, what we could do now through science is a million miles of what we could even think about back in 1980 or even 2000 when we published the results. What we can do today was unheard of back then. So we're looking at where these people came from, like mobility. Can we actually see more about their diet, which we can do through isotopic work?
My name is Dr. Orsia, and I am a bioarchaeologist and a specialist technician in paleoenvironment and archaeology. So my role essentially focuses on understanding past people better and their environment. I can do this through different means. In particular, I'm looking at bone chemistry as well as teeth sometimes when I'm lucky enough, hair and nails as well. And I try to learn more about people's diet and also where they came from in different periods through time. So if you think about it, the culture that we grew up in and even our religion will influence our eating habits. So as archaeologists, by studying these patterns, we can learn more about things like cultural or economical shifts in the past. For example, what did the elite eat in certain periods and what did the everyday people would have been eating? Where did the people come from to an urban area, for example? We can also potentially identify whether they were local to a region or not. So in an essence, we are what we eat and we are also where we eat. Edinburgh developed into the large urban centre that it is today from a relatively small settlement. But from the 12th century onwards, the city engaged in large trade as well. And St Giles within the city is in a really prominent location. It's of course on the Royal Mile. which also meant that it was a really popular burial ground amongst the people within the city as well. And those with wealth and authority would have sought to be buried inside the church itself, while the cemetery would have been open to the wider public. And we also know that the earlier phases are in particular the wider community of Edinburgh, and this is also kind of represented through the human remains themselves. There's been some evidence of poor nutrition, in particular in this early phase, and the burial evidence suggests that the later phase is a more wealthy, a higher economic status phase as well.
Although DNA was discovered back in what was the 1940s and 50s, bringing it into archaeology really, I would say, only in the last 10 years has become a more common practice.
I'm Dr. Tom Booth. I'm a senior research scientist here at the Francis Crick Institute, and I work in the ancient genomics laboratory here. So in the ancient genomics laboratory, we extract DNA from humans and also faunal remains to look at the genetic history of humans and different animals through time. Across a lot of Scotland, because of the underlying geology, the soils tend to be quite acidic, so not very many human remains survive in large swathes of Scotland. But in Edinburgh, there's something different about Edinburgh, which means that skeletons do survive quite well and that the DNA is well preserved. So it's one of the few places in Scotland where we can get DNA from ancient skeletons. So we get mainly 3 different things, well 4 if you include disease, genetic sex, genetic ancestry, and the relationships between individuals. There's 3 of these little bones in your inner ear. This is called the incus, the anvil, but yeah, it's about 30 milligrams, so we just take one of these and then that's all the DNA that we need should be in there. So whereas previously, because sequencing was so expensive, we were looking at tiny little parts of the genome, that now we're getting millions of sequences distributed across an ancient individual's entire genome, which allows for much more robust assessment of their ancestry, their sort of disease susceptibilities, and then over sort of the long term, how the ancestry or the genetics of people have changed through time.
We have bioarchaeologists in our team, and they will drill these samples for us and give powder in a little tiny Eppendorf tube and pass that over to us. It's then my job to process that powder into a usable format to be sequenced. So we will extract that DNA, so we add buffers to sort of burst open the cells to retrieve the DNA from there and clean them up and prepare them for next generation sequencing. So we're one of the few ancient DNA labs that have these robotic systems, which means that we can produce 96 samples at a time, rather than if we were doing it manually, we'd maybe only be able to do 20 or so samples. We try to eliminate human error and also human contamination. So being able to eliminate this contamination then means we can hone in on what is ancient in that sample. So having the robotics there hopefully eliminates a lot of both cross-contamination between tubes and also contamination potentially from the environment and from us as scientists.
So we've received around 30 or so samples from the St Giles Cathedral, and they've already been through all the laboratory processes, and we've done the first stage of sequencing where we generate a little bit of DNA data to assess how well preserved these samples are. But what we also get at this stage is genetic sex. So we've been able to assign genetic sex based on the XY chromosomes to all of those skeletons that we screened initially, no matter how well preserved they were, because we only need a small amount of data to be able to assess genetic sex. So in particular, the bones of children, there's one child that is having a facial reconstruction done where the sex was uncertain. We were able to say from the genetics that it was a girl.
But also we're doing facial reconstructions, and that's been a technique that has been on the go for decades. Now with new modern computer graphics, we can actually do 3D modelling. It brings it all to life in a new perspective, and we hope that the aDNA work will actually recreate what that picture actually really looked like, rather than the best guess that we could do today.
My name is Dr. Maria McLennan, and I'm responsible for creating the facial reconstructions as part of the St Giles project. I think one of the really interesting and important things about facial reconstruction in archaeology is in bringing these historical figures of interest to life again. It's a really interesting way of engaging the public in a kind of human way, to shed light on what these individuals may have looked like from our past. So the work that we do is very much an interdisciplinary and collaborative process. We use the science and the anatomy of the skeletal remains that we're working with, primarily the skull. We also use artistic techniques and techniques rooted in the visual arts, craft and design.
There's been dramatic developments with facial approximation, facial reconstruction over the years. What you would find is that a lot of the early science that was used was very kind of observation-based, quite informal. So something that we've seen actually across the forensic sciences in general is that there's been dramatic developments in terms of the technical methods in which we go about collecting data, analyzing it. And one thing that you need to appreciate when you're looking at a facial approximation is that you've got so many different technical standards that's being applied to support the approximation of every detail of the face. So everything from the opening of the eyes, like how wide is the eye opening, the shape and size of the nose, shape and size of the lips. You've got all these kind of fine details kind of written into the skull that we're trying to encode and understand through research. So when we're producing a facial reconstruction, the first and foremost detail that we look at is, of course, the surface of the skull and extracting all the kind of essential metrics and shape information that we need from this. But of course, with the advancement of science and access to resources like DNA, stable isotope, we thankfully have references to color through DNA. So it gives some inference to skin complexion, eye color, iris color, hair color and texture. And this is something that can feed into the reconstruction where without it, then, well, essentially we're having to base it on maybe population norms in an archaeological context.
The process of undertaking a facial reconstruction in 2025 is fairly heavily reliant on digital tools and technologies. So the specimen that we're working with for this project are quite heavily fragmented. So we use specialist 3D scanners to take scans of each of the individual fragments, which are then imported into a specialist software where we assemble those fragments together. So we're provided with as complete a specimen as possible. So I'm just in the process of applying all of the facial soft tissue depth markers, which will essentially act as guiding blocks really for the application of muscles, which will then act as a guide for the application of the skin and the facial features. And we then shape these individual muscles around the morphology, the shape of the skull, and that really starts to allow us to get the first impression of what the face might look like. And the process really is just the same as sculpting clay in a traditional sense with your hands. We have a specialist little haptic arm device which allows us to kind of digitally sculpt the digital clay in this kind of different dimension. So one of the first facial reconstructions we performed was SK103, which was actually one of the earliest specimen that we uncovered. So this was a lady who was estimated to be between about 25 and 35 years of age, expected to live actually around the time the cathedral was constructed, and actually would have been quite old, quite well-aged for that particular era. So this was a really lovely reconstruction to perform, particularly to be the face of this project, as she probably was one of Edinburgh's earliest inhabitants.
What we're looking at is the individuals, the everyday man in the street. These are the general population member, a population that's often hidden from history. We obviously see the great paintings of the elites, the nobles, etc. This is actually putting a real face on that individual. And as an archaeologist, telling the story of Edinburgh and the people, that's, to me, really exciting, because you're staring at the face of somebody who actually was part of a momentous part of Edinburgh's history, the foundation of the borough and the construction of St Giles Cathedral.
Well, churches are not generic. They vary from where they are and who comes around them, where they're located, and the people, therefore, that are around them. These people that we're looking back onto were once part of the story. They were people who formed, shaped, coloured, flavoured the life of St Giles. They would bring in their concerns, their hopes, their fears. They would mark their rites of passage here, birth, marriage and death. We're still doing that. And today's people are coming here for many of the same reasons as these people came, although what they would do it and how they would do it would clearly be different to what it is today.
I find this kind of work really rewarding because these individuals can no longer speak for themselves, they can no longer tell their own stories, and I think kind of humanizing the otherwise quite clinical or binary human remains that we find in terms of skeletons or otherwise is a really rewarding process to be able to give people back their image, give them back their identity, and really allow us to connect with our ancestors from the past.